Okay, Alicia, what I've got here is problem number 10 off the review. I went back and looked, and it looked like those were the two that you hadn't worked yet, 10 and 12, the ones that you just messaged me about. Anyway, 10 is an inequality, basically, where you've got a quadratic equation here that we're dealing with. And they'll call it a polynomial inequality, I guess, in the textbook. But I like to kind of get a picture of what's really happening here because I think that helps to kind of make all this make sense, okay? Because we know that this is a quadratic equation, right? Which graphs a parabola, which looks like either upward facing or downward facing. Yours is upward facing because of the positive coefficient here. And I know that it crosses the x-axis at -4 and -1 because of how it factors down. So I kind of tried to get you a sketch to show you that the places where this graph is actually greater than or equal to 0 are what I sometimes call the wings of the parabola. Okay, so it's two completely separate intervals here, and we're going to go and prove that process through the step-by-step process that you go through, you know, in the textbook whenever we originally learned this stuff. What they don't really point out is kind of what's really happening here is this picture, and I think that really, really helps to kind of make this very clear, okay? So what the textbook will walk you through is creating your separate intervals based on these crucial points. They have a name for them. I'm not sure exactly what they called them, but anyway, they're obtained, you know, by factoring it or whatever, okay? So your intervals are going to go from -infinity to your first point of -4, and then you'll have an interval that takes you from -4 to -1, and then you'll have the interval that takes you from -1 to infinity. So depending on how many different crucial points here, will determine how many different intervals you had, okay? So anyway, this interval here, you have to get you a test point, and I just got -5 because it falls within there, and then I got the -3 here. There weren't very many choices, and then I get the 0 here. Anytime I can get the 0, it's a real quick, easy test point. And then you'll see me doing over here is substituting those values in to the original equation here. Your -5, for example, so in other words, it ends up saying, is 4 greater than or equal to 0? Well, yes, it is. So therefore, this interval will make it to our solution set. And then trying your -3 or substituting your -3 again into that original equation comes up with something like, is -2 greater than or equal to 0? Well, no, it's not. Therefore, I put a line through here because this interval will not make it to our solution set. Last but not least, substituting in the 0 that we could use here ends up with this 4 greater than or equal to 0. Well, yes, it is. Therefore, this interval will make it to our solution set. And it's exactly like the picture says. From -infinity all the way to -4, you are greater than or equal to 0. And then you pick up when you cross that x-axis again at -1. Okay, so these green shaded spots are what are making it to our solution set, okay? Another thing I did here at the very end is I put brackets around those actual values there because of the inequality here getting to be equal to 0, greater than or equal to 0, because at those identical points is where we are equal to 0, okay? So you want to include those in your solution set.